this function with respect to x is given as x to the power n plus 1 divided by n plus 1 plus c. So this is true, right, for all n except a case, anyone? Except for n equal, anyone?
-1.
-1. That is, if it is -1, that would be a log function, right? So those who are sending messages to me on the chat, please note that the quiz answer expected on the same day within the time period. So if you have not submitted the quiz, it will go as not submitted, because cannot be accepted the quiz afterwards, quiz answers after the words, right? So those who have missed at the end of the class last week, you missed the quiz, so I cannot do anything beyond that, right? Sorry for that, because that is why at least you'll have to be in a place where you have a good receptivity with your connection. So I cannot do anything beyond that, right? So everyone, that is the condition. That is the disadvantage of having this high technology. If you are in the class on ground, we don't have that problem. But unfortunately, I cannot help in that sense, right? Okay. Try to do the rest of the quiz. So that is the only option. So we have roughly 3 more quizzes. So do it then. Right. Any questions on integration up to now that we have talked about? We talked about 2 types of integration. One is indefinite one, right? The other one is definite one. So definite one, indefinite one, as you all know, we are not sure about what is the constant. Ultimately, after you integrate, you add a constant. So we are not sure about the value of this constant, not exact value of the constant. So that is why it's called as indefinite. But in definite integrals, we get the integration for a range, so that the c will be cancelled off, so that we don't have any problem with c. Whether to include or exclude, we don't have any problem. Right? Right. So we have gone through several examples of integration using different type of rules. All these rules are to solve different kinds of integration problems. Right. Today we are going to start another technique, right, which is called as integration by parts. Look at very carefully. Integration by part. Suppose, let's say y is a function which is staying as u into v. Y is a function which is stayed as u into v. Normal function. If you differentiate y with respect to x, if you differentiate y with respect to x, how we could write it? Recall your differentiation rule. If you differentiate y with respect to x, how do we write? Anyone?
U into delta V over delta X
dv by dx, okay,
plus
plus
V into
v into,
delta U over delta X.
okay, right. So we can write it like this, okay? We can write it like that. So this is how we can write. So this is a denominator is a common term, isn't it? For everyone, denominator is common term, so that we can write dy is equal u into dv plus v into d. Do you all agree? Right. What is derivative of y? Can I write like this? Derivative of y is actually derivative of u into v, because y has been defined as u and v. That is equal u into dv plus v into d. We can write like this from what we have learned, right? So if we can write this as here, right? If u and v are two functions, if u and v are two functions, then on this line we could write it as that derivative of uv is equal u into dv plus v into d. Right? Okay. Now I am going to put an integration for all the components. So if you integrate the left side, you'll have to integrate the right side also. So integration of derivative of uv is equal integration of u into dv plus integration of v into d. I simply want to integrate these functions, right? Right. What is the integration of derivative of uv? If you integrate the derivative of uv, what is the function? What is the results? Integrals. We are integrating the derivative of uv. If you integrate the derivative of uv, Lovicia? Lovicia or?
Yes, sir.
Yes. What is the answer? If you integrate the derivative of uv, what is the answer?
UV plus C.
Yes. Forget about plus c. It is
Okay.
uv. If you integrate the derivative of uv, it is uv. Do you all agree, everyone? So uv is equal integration of u into dv plus integration of v into d. So there's a relationship between these three components. So from that, the rule is you integrate integration of u into dv, we are rearranging it, is equal u into v minus integration of v into d. So this is the template or the rule that we are going to use it for the integration by parts. Integration of u dv can be written as u into v minus integration of v into d. So this is the rule that we are going to use it. That means we want to identify a given situation. We want to identify these two components. We want to identify in a situation or given function. We want to identify what is u component, what is dv component. When you identify these two components, there's a priority identifying which one is the first, whether identifying u as a first component or dv as the first component. So that is a condition. Let's look at what are the condition rules. Identifying this u and dv of a function. How to identify this u and dv? Right. The first rule says the factor dv should be, you see, so which factor has to be identified first? The factor dv, right? Select that. So that one can get the function. One can get the function v by inspection. So that means first we'll have to identify dv in a function. We will see it with an example. So we want to identify dv. Once you identify dv, it should be convertible to v. What is this process? dv to v, how do we call that process?
Integration.
Yes, integration. So that means first we'll have to identify the dv and we should be able to see whether we can integrate that function. If so, then it will be considered as v. Okay? Right. One more point on the same concept. Constant of integration. Constant of integration is not needed for constant of integration is not needed for. That means we don't consider constant along with dv. So keep that constant away. Right. So now we have identified dv first, then no other options, identifying the second component as u. Right. U is, we find out, u is a factor that would lend to become a simpler form when differentiated. Right. Now we want to find out u as the second component in the function. Then we'll have to differentiate them. Right? So what we try to say is one by one. In the first rule, we say we want to identify dv first, right? Then we'll have to convert this into So this is called as integration process. In the second step, we want to identify u. We want to find out the derivative of u. So that is called as differentiation. All are with respect to x, right? So that is called as differentiation. So this is the first step, identifying dv, then converting into v. The second step, identifying the u and converting into d or derivative of that. These are the two steps. Any questions before I take an example? Let's take a function x cos x dx. So here x is one component multiplicative with cos x. Right? Now here we have to find out dv first. Let's say my dv is equal cos x dx, because dv has to go along with the dx because it is a derivative. So for the integration function, dx has to be there. From that, what is v? Anyone? If dv is cos x dx, what is v then?
Sin x.
Sin x plus c, but we don't want to put c now. We will put it at the end. Well, it will complicate. So we will put the c at the end. Right. Then what is u? So if this has been considered as dv, what is u? U is x. So what is du by dx? Is equal 1. So that means du is equal dx. Is it clear to everyone? Right. Now we fill the blank. What is the blank? Our function. Integration of u into dv, I'm rewriting it as u into v minus integration of v into dv. So this is my rule. I have all the components now. Fill the blank. All the components, fill the blank. First one is integration of u into dv, that is x into cos x dx. That is the function that we want to solve it. That can be written as u into v. What is u? U is x into v. V is sin x minus integration of v. What is v? Again, it is sin x into du. So we'll have to write in terms of dx. So that is dx. Because du is equal dx, that is dx. Any questions? Asad Khan, can you mute it? Any questions? Right. So this is the first step. We haven't solved yet completely. So this is the first step. So this function can be written as this. So x into sin x, nothing to do with that, minus, you'll have to integrate sin x. So if you integrate sin x, what is the answer? Now you should be thorough with your integration, differentiation, especially with trigonometrical function. How does it change? If you integrate sin x, it becomes as anyone?
Minus cos x.
Minus x. It looks like only Lovantia is in the class. Huh? No one is opening their mouth. Minus cos x plus c. Right? Now we can rewrite it as x sin x plus cos x plus c. So this is my final answer. Right? Okay. Any questions? Right. Another one. Integration of x sin x dx. Right. Integration of x sin x dx. Again, can you try it? So I will give a hint. dv can be considered as sin x dx. U can be considered as x. Can you proceed and see the answer? Anyone? So from here, you can write it as v is equal minus cos x. Here du is equal dx in simple form. You fill the blank. So integration of u into dv, that is sin x into sin x dx, is equal u, that is x into dv minus cos x minus integration of minus cos x, which is your v into dx. So that is equal minus x cos x. If you take the plus out of integral, then it becomes plus integration of cos x dx. So if you integrate cos x, what would be the answer? Anyone? It would be sin x. So this is my final answer. Sin x plus c. Right. Look at another one. X ln x dx. Another example. X ln x dx. Tell me which one would be taken as u, which one would be dv. First, we'll have to find the dv, then u. Anyone? Which one we can identify dv first?
ln x dx.
Okay. dv is equal ln x dx. Right? Then what is v? from dv to v, that we'll have to integrate this function. So if you integrate that function, what would be the answer? So this, what would be the answer? So we haven't done this, so we can't find the answer. Using dv as the ln x dx. So therefore, I can try some other technique. I consider dv as x dx. If I say x dx, what is v there? Anyone? You integrate the function x. If you integrate x, what is the answer?
X squared by 2.
Right. Now, what is left over now? Once you identify dv as x dx, my leftover is u is equal ln x. Do you all agree? What is du by dx? Take out. Yeah.
1 by x.
Okay. 1 over x. Yes, 1 over x. Right? 1 over x. Right. Now you fill the blank. Integration of u into dv. So x into ln x. Order is not matter because it is multiplicative. Is equal u, that is ln x, into dv. dv is x squared by 2. Right? Minus integration of, right? Ishanka, mute it. Integration of, again, v x squared by 2 into du. Instead of du, how we can write this? So du is equal dx over x. So instead of du, we can write dx over x. Right? So that is equal. I can take this x squared by 2 into ln x minus, here the 1x cancel out. So take the 1 over 2 out of the integral sign. Integration of x dx. Is it? So that is equal x squared by 2 ln x minus half into integrate this function. If you integrate that function, that is x squared by 2 plus. So we could take x squared by 2 out of the bracket. Then you can say ln x minus half, right, plus. So this is my answer. Any questions? Right. Now, what is the integration of ln x dx? So we'll have to integrate that function also. Right? What is integration of ln x? Because if you take this as dv, we have problem. Earlier we have seen. So integration of ln x, we can identify dv as dx. Q as the ln x. So what is v here? Anyone? What is v there? Yeah. What is v there? How you can write this? What is dv by dx? From this dv by dx, what is that? Equal? Anyone? What is dv by dx from this? From this, what is dv by dx? Anyone?
1.
1. So what is v then?
Is equal to x.
Hmm?
X.
X, yes. Yes, x. Right? Yes, it's x. Right? So we found v. Now we could say du by dx is equal, as we said earlier, 1 over x. From that, du is equal dx over x. Right. Now fill the blank. Integration of ln x dx is equal to u, that is ln x, into v, that is x, minus integration of v, that is x, into du, which is dx by x. So here the x cancel off. So that is equal ln x into ln x minus integration of dx. What is the integration of dx? X into ln x minus, what is the integration of dx? Anyone? We have just seen the outcome. What is the integration of dx?
X.
X, yes. X plus c. So we could say x is a common term, take out ln x minus 1 plus c. So this is my answer. Right? Any questions? Next one, integration of x into e to the power x dx. x into e to the power x dx. Let identify dv first. So if you identify dv as the e to the power x dx, from this you could say v is equal e to the power x. Integration of e to the power x. Then consider x as u, du is equal dx. Now fill the blank. Integration of x into e to the power x dx can be written as u, that is x into v e to the power x minus integration of e to the power x, which is v, into du, that is dx. So that is equal x into e to the power x minus e to the power x plus. So that is equal e to the power x, take out from the bracket, x minus 1 plus. Any questions? Right. Further, we'll do one more examples on this line. Can you integrate x squared e to the power x dx? If you integrate x squared e to the power x, again, my dv would be e to the power x dx. So v could be e to the power x. Similarly, u is x squared. So du by dx would be 2x. So du can be written as 2x into dx. So we need that du. Now fill the blank. Integration of x squared e to the power x dx is equal u, that is x squared, into v, that is e to the power x, minus integration of v e to the power x into du. Du is given as 2x dx. Right, now we want to solve what is on the right side of the equation, x squared into e to the power x minus integration of this. So this is a constant. Take the constant out of the integral sign. Now x into e to the power x dx. Now we'll have to integrate this component. That's all. Then we will combine. So have you seen integration of this ever before? That is same as this. Then integration of x to the power, integration of x into e to the power x dx. So how that can be written? How that can be written in this form? So I'm going to write that there, x into e to the power x, right? So from here, 2 into x into e to the power x minus integration of e to the power x dx. I'm just substituting instead of that, right? So you can have the front version as it is. So that could be the case. X squared into e to the power x minus 2 into x into e to the power x minus integration e to the power x. So we'll have to integrate this compound. So that is equal x squared e to the power x minus 2 is there. We can multiply later. X into e to the power x minus integrate this function e to the power x plus 2. So we could expand it x square e to the power x minus 2x e to the power x minus 2 e to the power x plus. So we could take out e to the power x, right? Then we can write it as x square minus 2x minus 2 plus. Any questions? Any questions, clarifications? Think have some examples in the tutorial you can try. Right. The last integration is integration of rational functions. Integration of rational functions. Normally, the rational function is R is given as the ratio between two other functions, P and Q. So this is called as a rational function, right? We have seen some rational functions earlier, which can be solved very easily, right? For example, integration of x by x plus 1. Integration of x into x plus 1. Okay? X into x plus 1. Give me a second. So this is a rational function, right? Another rational function, integration of x plus 1 divided by x minus 2 into x minus 3. This is another rational function. So how to solve this kind of functions, right? For example, integration of 1 over x plus 1 dx. This is a rational function. Can you remember? We did earlier. So how we can integrate this function? Anyone? What is the answer for this? To integrate this function, what is the answer? The derivative of this, whether it is found in the numerator, derivative of denominator, if it is found in the numerator, then it is a log function. So we can write it as, if you integrate that, log x plus 1 plus, is it? Similarly, integration of dx by x plus 7. So the derivative of x plus 7 is 1. So that is found in the numerator, so that we could write it as log x plus 7 plus 6. Easy one that we have seen, right? Can you remember integration of, can you remember integration of x squared 8 dx? How we can write this? This we can write it as integration of 1 over 2 into 2x dx by x square plus 8, isn't it? And write it like this, isn't it? So the derivative of x square plus 8 is on the top, which is 2x. So we could write this as half into log x square plus 8 plus, can you remember? We did already. Last week, we have seen. So we can solve these integrations, even though they are rational functions. We can solve them using direct relationship. But there are certain cases you cannot solve it. For example, take this integration of x minus 1 divided by x plus 2, x plus 1 dx. So this is also a rational function where we cannot directly solve using earlier techniques. Right? Now, what is the techniques available for this? Right? What is the technique available for this? So this can be written as integration of a dx divided by x plus 2 plus b dx divided by x plus 1. We can write this in a different forms. So we can write it like this. Right? In another term, if you remove the integral sign, we could say x minus 1 divided by x plus 2 into x plus 1 is equal a divided by x plus 2 plus b divided by x plus 1. So we can write it like this. We can write it like this. Okay? Now we can solve it using mathematical knowledge. So what is on the left side is equal to what is on the right side. So I'm going to solve this, right? A into x plus 1 plus b into x plus 2 divided by x plus 1 into, x plus 2 into x plus 1. Which is same as on the left side, x minus 1 divided by x plus 2 into x plus 1. So the denominators are same, but we are comparing only the numerators. X minus 1 is equal a into x plus 1 plus b into x plus 2. Now we can expand ax plus a plus bx plus 2b. Now we can rearrange what is on your right side according to this. So what is the coefficient of x? The coefficient of x is 1. Right? This is a constant. So we can write it in that term. So I'm going to write it as bringing a x plus bx plus a plus 2. So further I can write it as a plus b into x plus a plus 2b. So here, this is the coefficient of x on the right side. So we could say coefficient of x on the right side is equal to the coefficient on the x on the left side, which is 1. So that is my first equation. Second equation is a plus 2b, which is constant, is equal minus 1. So this is my second equation. Right. Can you find out the value for A and B in a simple form? I have two equations. Can you solve the equation and get the value for A and B? Get me the value. What is the value for A? What is the value for B? Value for A and B.
A for 3, B for -2.
Yeah, once again.
A
A,
for 3,
A,
B -2.
right. Anybody getting a similar answer? The same answer?
Yes, sir.
Okay, right. A is equal 3, B
Minus.
is equal -3. Now, going back to the function, right? So what was the function? We want to integrate x minus 1 dx divided by x plus 2 into x plus 1, which is equal, we have already said, it is the integration of a dx divided by x plus 2 plus integration of b dx divided by x plus 1. So this is what we want. So this is on the left side is equal to the right side, where we want to find out the value for A and B, which we did it already. So it is the integration of 3 instead of A divided by x plus 2 minus integration of, because B is minus, 2 dx divided by x plus 1. Right. Now we can solve it. How to solve it? So we could take this 3 out of the integral sign, 1 over x plus 2 dx minus 2 integral 1 over dx x plus 1. So the answer would be 3 into log x plus 2 minus 2 into 2 into log x plus 1 plus c. Okay. Any clarifications, suggestions? So this is how we can handle some of the rational functions if we cannot do it directly. Right, take another example. Right, integration of x minus 16 dx divided by 2x minus 3 into x plus 2. This is what we want to solve it. That we can say integration of a dx divided by 2x minus 3 plus integration of b dx divided by x plus 2. All right. So that is equal. We could say integration of a divided by 2x minus 3 plus integration of b divided by x plus 2, which is equal to x minus 16, right, divided by 2x minus 3 into x plus 2. Again, the same concept as earlier. We could write it as a into x plus 2 plus b into 2x minus 3 divided by 2x minus 3 into x plus 2, which is equal to x minus 16 divided by 2x minus 3 into x plus 2. So denominators are same, so that we could say the numerator, we could equalize the numerators, which is ax plus 2a plus 2bx minus 3b. Let us rearrange it. Ax plus 2bx plus 2a minus 3b. So that is equal. Write it as a plus b, a plus 2b, is equal, sorry, into x, a plus 2b into x plus 2a minus 3b. So a plus 2b is equal 1. That is your first equation. 2a minus 3b is equal minus 16. That is your second equation. Can you find out the values for a and b? Everyone, can you find out the value for a and b? Anyone, answer for a and b? Anyone? Answer for a and b? Bruce? Susanna? Yeah.
So B is equal to 18 by 7. A is
Oh,
equal to minus 29 by 7.
I'm getting a different answer. Anybody else?
A is 43 by 7.
A is 43.
43 by 7.
B
B minus 18 by 7.
minus.
18 by 7.
I'm getting a different answer. Anybody else? I'm getting an answer like this.
A is equal to minus 3, B is equal to 2.
I'm getting a different answer. That is also.
A is 5, B is minus 2.
Yeah, that is right. I'm getting a different answer. This is my answer. Right? Okay. So 5 and minus 2. So we can substitute that integration of instead of A, 5 dx by 2x minus 3 minus integration of 2 dx by x plus 2. How to take this? Here you see here if you differentiate 2x minus 3, what is the answer? It will become as 2, but here we have 5. How to write it? You can write it as 5 by 2 into 2 dx divided by, isn't it? We are multiplying both cases by 2. 2x minus 3 minus integration 2 into integration of dx x plus 2. Right? We can write like this. That is equal 5 by 2 log 2x minus 3 plus, minus 2 log x plus 2 plus right. That is how you get the answer. As a homework, you can try this. Example, integration of x minus 7 dx whole thing divided by x square minus 4x plus 3. How to integrate this? Similar to earlier. Look at the denominator. Denominator is not in the same format as we. So how we can write this as x minus 7 dx factorize. Yes, factorize. If you factorize this, how we can factorize this? What is the answer? Factorize. So this is where we are using our factorizing knowledge.
X minus 3, x minus 1.
So now we can do it, isn't it? Now we can. So this is your homework. You can try. Right. Any questions? So that's all about the integration. Let's look at a little on application of integration. application of integration. First one. Area on the curve. Area on the curve. Right? When you talk about area under a curve, you have x-axis, you have y-axis. Let's say y is equal to function of x. A function has been given, right? Now I want to find out the area between A and B of a value of x above the x-axis. So that is the case. We will see little on application why we want to get the area. Right? Any area could be calculated. Area under the curve. First one is above x-axis. So that is given as, right, the area is given as integration of the function given there with respect to x between the range of a to b. A is the lower value of x, b is the upper value of the x. So we can find out the area, right? For example, if I have a function x to the power 3, right? If I have a function x to the power 3, okay? So I want to integrate that function between 2 and 3. So what you do, you first integrate the function, then you substitute the value 2 and 3, which is called as definite integrals. Can you remember? So that is equal 3 to the power 4 by 4 minus 2 to the power 4 by 4. If you get this answer, that is the area under the curve between two values of x above the x-axis. Above the x-axis. Any questions? So this kind of things we have seen already. Then we will go for the second one. Right? Let's say we have a function, it's the same function. Doesn't matter whatever the function. So now we want to find out the area below the x-axis. Y is a function of x. Right? This is x-axis. This is y-axis. So we want to find out the area below the x-axis between the x value of an. Right? So if you get the area, let's say this is area. Area is actually integration between your upper and the lower value. Right? If you integrate this function, this function is actually giving a value in minus. This function will give you a value in minus. So what you need to do is you get the absolute value. Can you remember we spoke about absolute value? Take the absolute value. Right? You take the absolute value of this. Because you will get a minus value. Right? So area cannot be minus. So you'll have to get the absolute value. Take the absolute value. Right. Now, a case like this. The third case, area under the curve. So I have x-axis and y-axis. Let's say I have a function y equal x to the power 3. Y equal x to the power 3. I want to find out what is the area enclosed between -2 and +2. I want to find out the area between. So if you come up with area is equal integration of given function x to the power 3 dx with respect to x for the range of -2 to +2. -2 to +2. Can you find out the answer? I will give you a couple of minutes, find out the answer. What is the answer? Any question? Any answer? Anyone else?
0.
0. Right? Actually, look at the area. Can we say the area is 0 here? Look at the area. Can we say area is 0 here? Here we have some area. Here we have some area. But we come up with 0. So what to do? Because what is happening? This is coming with a positive value. This is coming with minus value, negative value. So they will cancel out. So area, we cannot say here the area is 0 for a given range. Obviously, there's an area. So we could say what we'll have to do is we'll have to integrate these functions separately. So we'll have to integrate this function separately. That means because it covers from -2 to +2. So what we could do is first we'll have to integrate from 0 to 2, which is a plus above the x-axis of the x to the power 3 dx, plus absolute value of integration of the same function with respect to x from -2 to 0. -2 to -2 is the lowest value, 0 is the upper value. So we want to integrate that function between those two values for the after integrating you get the absolute value. So get the absolute value. Right? Right. So that is one concept of area under the curve, sorry. Area under the curve. The second application, area between two curves. Area between two curves. Let's say I have two functions. Both functions are above x-axis. Let's say y is equal, let's say y1 is equal function of x. Where is the second function? Right, y2 is equal function of 2x. Just indicating those are two different functions. Now, for a given x value, let's say a to b, for a given x value a to b, we want to find out the area between these two. Right? Tell me, what do you mean? What is the application here? Tell me one application why we want to find out area between these two. Anyone? Think about any field. We can think in agriculture very easily. Why we want to find out area between two curves above x-axis? Similarly, if I give one example here, what is the use of calculating the area here, the application, above x-axis? Tell me. Most of the economist does this kind of calculations. Anyone? What is the application of it? For example, area under the curve. You take, say, as an example, let's say rainfall throughout the year is the first month, second month, up to 12 months. Rainfall up to 12 months. Right? Doesn't matter whatever the graph. It has been given as a function. We don't know the graph. It has been given as a function. Now let's say if I want to find out what is the total amount of rainfall between a particular month, let's say 4 to 6, right? I want to find out the total rainfall between 4 to 6 months. Then we can integrate this function. If you integrate this function, right, with respect to x for the range of 4 to 6 months, as an example. Another example, let's say our production, maybe paddy production or onion production or milk production, whatever the production, 1 to 12 months again. Easy if you take it monthly. So it has been given as a function, the production, paddy production, because paddy production is not same throughout the year. Onion production is not same throughout the year. Milk production is not same throughout the year. Egg production is not same throughout the year, right? So you can have any production, not only agriculture, even other productions, right? Maybe textiles, etc., etc. Right. So this production has been given in terms of the function. Now I want to find out what is the total production for a given month, A to B. So let's say if this is A, this is B. So I want to take the total production between these 2 months. So if you integrate this function between these two values, that will give you the total production. Okay, we will see an example later, the real example. Similarly, here, the second way, what is the application of getting value for, area for in between two curves, two functions? Can somebody think in the same line as I spoke about? One example is nowadays prices. Price. Let's say this is again from 1 to 12 months. This is production. Let's say rice production. Rice production. This is my production. Y1. I will say Y1 is equal Fx1, F1x. That is my rice production. But sometimes we are not fulfilling our total requirement. This is the country's requirement. Y1 or Y2, F2x. Country's requirement. So for a given time period, as an example, what is this shaded area? Anyone? Or marked area? What is this marked area?
Shortage amount of rice.
That is coming. This is demand. This is supply. Demand and supply. So this is the amount that we need addition, so that policymakers or the government think about during this period how much that they need addition, right? So that they can say they can plan for importation. The importation, because they'll have to supply some more for a given period. So think in that terms, right? So these are very important in that kind of application. Okay. So during which month the dropping is coming? I mean, you'll have to plan it well, because when you want to import it, you just give a call to abroad or maybe India. Tomorrow you cannot bring it. It takes some time, right? So that is a logistic part. So nothing to do with mathematics. So this is the application of finding out the area between these two. Right. For that, how we can work it out? For example, here I have one function, I have another function. So we can integrate these functions. We can take the difference between these two functions within the given range. For example, we can say y1 minus y2 two different functions because y1 is the highest value above with respect to dx. So if you integrate the function and substitute the value and get it, so that is the surplus or whatever it is. Shortage or surplus depend on where the demand is. The demand is above, then it is shortage. If the demand is below, then there's a surplus. So we can integrate these two functions and get that. Right? Any questions? Right. So these are the most important applications that we come across. Right? Then the third one, application. For a given y value, for example, earlier for a given range of x value, we found the y value. Now vice versa. For a given y value, how to find out the area, right? For example, let's say this is a function. I want to get the area which enclosed with the y-axis. This area. That is also possible. Let's say this is C, this is D, upper value is D, lower value is C. Then you can say, let's say this is the y is the function of, we will have to bring this function in terms of y. So that this area can be given as in between C and D, function of y. Function of y with respect to dy. So this is, we'll have to convert into y terms, function of y. Bringing in x terms. Okay. So for example, this function, if you have given y is equal 3x square as an example, then we'll have to bring it in these terms of y. Huh? So that is x square is y by 3. X is equal square root of y by. Right, do you see? So this is in terms of function of y. Okay. Right. Any questions? Right. Maybe we have very limited application on this. So we are not going to talk about that much. Right. Coming back to a little more on our paper, final paper. So I have 3 parts. Part 1, part 2. Both will carry equal marks for part 1 and part 2. 100 marks. Here also 100 marks. So that means the time is also equal. Right? Part 1, there may be direct questions, maybe 10 or 15 questions, depending on the time. Right? That means part 1 is similar to our quizzes. If you have done quizzes, right? So you find out the inequality of this function. You have to give the answer. You have to work out, give the answer. Find out the equation of a straight line, you give the answer. So those are direct. Right? So those are direct questions. The answer should be direct. Part 2 is more on application. Right? What do you mean by application? Right, I will give a function. Right, as an example, I will give a function. As I said earlier, the production function, onion production. This is in month, X is in month, Y is in metric tons of onion production, as an example. Right? Because onion production is not same throughout the month. First question is find the month of minimum production and maximum production. So what you will do to find out the minimum and maximum? Anyone? We have learned this.
You have to derivate the function.
Yeah. We'll have to differentiate the function. Right? We'll have to differentiate the function first. Then we'll have to find out the two x values. There will be two x values. That means which gives the turning points at these two x values. Then how to decide whether it is a maximum or minimum?
Second order derivation is needed.
Yes, you go for the second order derivative. We learned already. So based on the second order derivative, we decide which x value is giving maximum production, which x value will give minimum production. I have seen in some exams, so when you get the x value, what is the range of possible x values? What is the range of possible x values? Possible range, because x is indicating months in numbers. What are the possible values? Huh?
1 to 12.
Pardon?
1 to 12.
1 by 1.
1 to 12.
Yes. So this x value, 1 to 12 is possible. Sometimes when you have value like 20, x equal 20. Sometimes in the exams I have seen, so it is not logical, isn't it? You don't have a value x equal 20. That doesn't mean. So when you say 1 mean it is January, usually. Then 12 mean it is December, right? Think in that term. Right. That is one point. So you'll have to differentiate. Then you get the second derivative and you find out whether it is a mixed minimum or maximum. The second question is find out the maximum production and minimum production. How to do it? So here you found only the month, which month the maximum would be and in which month the minimum would be. But here I am asking the production, total production. Anyone?
It will be the turning point in the graph.
No, you are not going to draw the graph, no?
Oh, yes, sir.
So from mathematically, how you get it?
So if we derivate the function and if we have two x values, then we can replace that one in the given function to find the turn.
Yeah. So basically, if you have the x values, we know that, let's say this x value is minimum, this x value is maximum. So to get the total production from the original function, you substitute this x value one after the other and get the y value, right? Okay, so that is that y value will give you the total production at the month of maximum in the month of min. Right, one more concept here. Find out the production for March to July. Find out the production, total production to March to July. What you will do?
Area under the curve.
Yeah.
Area under the curve.
Yes, it is area under the curve. So that means March to July means March means third month has to be added with fourth month, has to be added with fifth month, added to be sixth month, added to be seventh month. So third, fourth, fifth, sixth, seventh month. So you want to integrate this function, given function, above function, right? So we want to integrate that function. So I'm saying the same function with respect to x. So what is the lower value and the upper value?
3 and 7.
7. Upper value. Lower value?
It's 3.
3. Any suggestion? Anyone? So here, once you get the derivative, right? Sorry, once you get the function, right? You can't say dash. Once you get the integrals, right? Once you get the integral, you substitute the value for 7 and 3. So if you substitute the value for 7 and 3, what are the months that is included here? Starting from 7th month, then anyone? 6th month, 5th month, 4th month. How about 3rd month? 3rd month will be excluded from this calculation. But originally I need 3rd month also to be included in the calculation. Right? So what should be this value then?
That should be 2 then.
So this value should be 2. Right? This value should be 2. So you integrate the function from 7 to 2. Is it clear? So you'll have to read the question very carefully. If I say total production June to October, so what would be the upper and the lower value? Anyone? I need the value including June and October for the range of the value.
5 to 10.
Yeah, upper value is 10. Lower value, you can't say June is 6. If you say June is 6, it is excluding the June. So it should be 5. So think in that term, right? Right. A few more on part 2. Those are the applications on part 2. Let's say I have a function, growth function. Growth function. Right? As an example, growth function. Let's say y is equal fx. or I can give it in dy by dx. I can give in this form or in this form. So this is simply we go growth function. How do you call this dy by dx in terms of growth? This is called as growth rate function for a given growth rate, right? So let's say if I have a function, right? Let's say I have a growth rate function. Some values are there, doesn't matter whatever it is. This is a growth rate function. You have two different terms, growth rate and growth. Okay? So if I ask you to find the growth function, this is growth rate function. If I ask you to find growth function, what you will do?
Integrate this function dy over dx.
Yes, you integrate this function. Find out the function. Integrate the function. Right? Right. Now let's say your growth. If I ask you to find out what is the growth of a plant, maximum growth of a plant. Because here I have two functions now. This function is integrated function, right? So I will put it as fx. This function coming from originally from here, it is integrated function. So I want to find out maximum growth of a plant.
First order derivation.
Huh?
We can derivate this. First, we want to integrate the function. Then we can find the growth function from the growth rate.
Yeah,
Then
indeed. Wait. This is a growth rate function that has been given. Now you ask to find out the growth function. So you have integrated, and that is the growth function. In the
again,
second question, I am asking maximum growth of a plant.
we have to differentiate this fx.
Differentiate which one?
fx.
Because already differentiated here. That is I mean, this is if this is integration. If you reverse it, it is a differentiation, isn't it?
Yes, sir.
Already it is given in the question, derivative. Derivative is given in the question as a growth rate. So you have already integrated that, right? Now I'm asking how to apply this maximum. Can you remember limit?
Infinite. Infinite.
Can you remember limit? Yeah, anyone? Madhu? Madhavika?
It's an infinite value.
Pardon?
It's an infinite value.
Yes. Let's say if you have given a function, right? This is my function, whatever the function, right? If it is in terms of x, so maximum growth, we can look at it because maximum growth, we assume in the function, we substitute x as infinity and get the answer. Can you remember the limits? Okay. Right. Then the rest of the questions are within this. I might ask what is the growth rate at 10 days after planting? So I might ask what is the growth 15 days after planting. So you'll have to play with these two functions. One is the function which has been given. So I can give either this function or this function, not both. I can give a derivative function. Then you'll have to integrate it to get the growth. Or I can give a original function. You'll have to differentiate it. Either way is possible. That I have not decided. So this is more application on the real world example. The part 2. Part 1 is purely direct, like what I am asking in the quiz, right? Direct questions. What is the equation of, if the equation of a circle has been given, you have to find out the radius and the coordinate. Direct. Right. Last time I mentioned about this is an open book exam, but there is a restriction. What is that? I mentioned about this.
Only
Anyone?
2 A4 sheets.
You can bring 2 A4 sheets.
Yes. So you can bring 2 A4 sheets. Huh? Anything that you can fill with this A4 sheets. Anything as you like. Right? You can bring calculator. Non-programmable calculator is allowed. Right? Non-programmable calculator. Just adding and subtraction. Scientific calculator would be fine. Right? Answer books will be provided by PGIA, so no problem. You need only that. Only this 2 sheets of A4. If you like, then bring a calculator and material for writing and so on. And definitely you bring your ID. ID mean if you are already PGI student, PGI ID, PGI student ID, or otherwise the national. Those who are joining with the national ID, bring the national, right? And the examination will be on 5th of January. It has been already scheduled, right? January, 5th of January. I think 9 to 11 you have stat exam, basic statistics, and 11:30 to 1:30 you have maths. Right? We will be informing anyhow to everyone. You can any questions on examinations? Further?
Sir, excuse me, sir.
Yeah.
Yes, sir, can you describe again the find maximum growth of plant, the limits, that part?
Yeah, that is, for example, function is given 3x square or something, right? 4x plus 8x. This is your function, right? So if I ask you to find out, this is the function that you have come across, right? So now what is the maximum growth? Maximum growth, for example, is x and this y. So the maximum growth happens when x equal infinity, isn't it? When x equal infinity, that is how you get the maximum growth. So here instead of x value, I will give a normal function, right? Let's say y equal e to the power 3x square plus 2 as an example. So instead of x, you get a value y equal e to the power 3 infinity square plus 2. So you'll have to solve this for the value of y. Okay? Got it?
Okay, thank you, sir.
So this is, I mean, instead of x, you substitute the value infinity. Right. Any other clarification? Right. We have a couple of more minutes to have a break. We are going to start with a new topic. That is why I'm waiting. We can start after the break. Any questions? We can spend about 5 minutes, 6 minutes answering the questions. The last section is coming after the break. Yes, scientific calculator is allowed. Scientific calculator is allowed, right? But non-programmable calculators are allowed. Non-programmable. You can ask the question rather than putting in the chat.
So is there any semester or course relevant to this maths after this first semester one?
I didn't get
I registered ST5101 and it's belongs to semester 1 according to the academic instructions I show. Is there any semester part related to maths? Any second course related to it?
No. This is
Okay.
these courses are prerequisite courses. Just you'll have to get the pass mark.
Okay, sir.
This
Okay.
will not give any grades.
Okay,
It
sir.
will
Thank
not
you.
carry into a transcript either. I mean, they will say you just followed and passed.
Okay, sir.
It will
Thank you.
not come for GPA calculation, right?
Yeah, thank you. Thank you, sir.
That is why we are offering this. That is why we are offering before this actual semester starts.
Yeah, okay.
The examination going to be physical exam. No? Examination is physical. Huh? No online exams, only physical exams. So you'll have to be present at Peradhan on that day. Any other? Because not only for stat, not only for maths, for stat also it is same, physical examination. So you'll have to be present there by physically. Any other clarification on what we have covered up to now? Because we
Sir,
are going to have a new section which is irrelevant to the section that we have already learned. Matrix
sir,
ID. Yeah.
so in the previous function,
Yeah.
e power infinity should equal to 0, sir.
Don't worry. The question I will put it in such a way. Don't worry. You will find the answer. I cannot give exact formulas now. So in a formula, this is how you'll have to apply. That is what I showed you. You see? This is how you apply the value, right? Because I said instead of x, you apply the value infinity. That's all. The answer, it's up to you all. You get the answer correct. Right? Because I cannot give exact equation now. Then it is no point. Yeah. Anybody else? Who asked you, can you give the recordings? because always look at the chat box. The recordings have been already in Google Drive. Look at the chat box. I think today also we have put in the chat box recordings, detail.
Okay.
Look at it.
Okay, sir.
So,
Okay, sir.
because we are telling this is from very first day. So all the recordings are there. Right. Any further questions? If not, any questions? Right. If not, we will go for the break. After the break, I will start a new chapter. Right. Okay, we can continue. Yeah. Uh, right. Regarding the remaining lecture hours, 28th and 29th of December, no lectures, huh? That we have already informed through the timetable. So the last lecture will be on 4th January. And we are planning to have the exam on 5th January. Right? So I'm not sure people who are traveling from far end, how you can manage it, that I'm not sure. Yeah, somebody has already. So we'll have to, because it has been scheduled, because both exams on 5th, mathematics and statistics. Anyhow, both exam will be held on the same day, right? Yeah, I can understand the issue of, especially people are coming from far away. Oh, we can have the exam a little late, maybe afternoon. We can discuss that and let you know. Exam maybe starting at 1 to 3 and 3:30 to 5:30. That is the other possibility. Anybody, any comments? That is the other possibility that we can having the exams in the afternoon, not in the morning. Yeah. Anybody comments? So you can, those who are following statistics also, you can mention about this to Professor Samita, then we will see whether we can have it in the afternoon. So that is the possibility. Somebody said that time is good for us. What do you mean by that time? I didn't understand. Morning or evening? Yeah. Right. We will see whether that is possible, right? 1 to 3 and 3:30 to 5:30. So this is the other option that, right? Ishanka, can you mute it? So mention this to in the evening lectures to Professor Samita also. So we are flexible, huh? We are flexible to have the exam on 5th, either morning or evening. So we cannot fulfill everything because this remember, this course is priorities to people who are registered this year, 24 batch, not for other batch, right? So other batch you are repeaters, so you'll have to come for that. No other options. So the priority given for the freshly following batch. Right? Because somebody asked whether we can start at 10:30. That is also possible, but everyone has to agree, right? Because the people who are coming from far away, I'm not sure how. Right. Anyhow, without wasting time, to think about it, we have still time, right? Right. Now I'm going to start a new topic that is called as matrix algebra. So this is the second part of your course. Could you remember the course title is Calculus and Matrix Algebra. So we have done the calculus part. Now we are going to the matrix algebra. First, we will understand what is this matrix, right? Most of you might know what is this matrix. Definition, a matrix is a rectangular array of numbers. Matrix is a rectangular array of numbers. Right? For example, let's say A is a matrix called as, it has some numbers. Right? So here, this is called as rows. This is called as column. Right? Rows and columns. So this particular matrix is having how many rows? Two rows and 3 columns. Right? Similarly, another matrix, 2 rows and 1 column. Right? Similarly, here 1 row and 3 columns. So this matrix, as we said, it is a kind of rectangular arrangements of numbers, right? The number of numbers of a matrix are called as entries or elements. The numbers of a matrix are called as entries or elements. Entries or elements. Okay, so these are elements or entries, these numbers. All right. Also, the size of a matrix, right? Is given by M into N. M is the number of rows, N is the number of columns, number of rows and number of columns. For example, if you say a matrix A, right, in our earlier case, matrix A with a size of 2 into 2. So 2 rows, always you write the number of rows first, then number of columns. 2 into 3, that is 6. Matrix B, right? Two into 1. So this number 2 into 1, that means 2 is equal, it is the number of elements or entries. Number of it indicates the number of elements or entries, right? Right. Let's take a simple example, very old example. Let's take television sets, right? As I said, the old example. Those days we had black and white television and color television. 2 types, right? And the size of the television, there are 3 different sizes: 12-inch television, 14-inch television, and 20-inch television, as an example, right? So how we can put this into different category, right? For example, 12, 6, 10, 3, 7, 4. Here this is black and white. Column wise it is color, black and white and color television. Row wise, small, medium and large. So this is small, right? Medium and large. Small, medium and large. Right? So the same thing we can produce in other way. The same information, because here we have sold 12 in a television shop, right? In a shop, the sale of a month has been categorized like this: 12 black and white small sold in that particular month, 6 color small television sold, and so on. So here this can be represented slightly in a different way, right? That is 12, 10, 7, 6, 3, 4. So this is black and white. This is color. So this is small, medium, and large. So we can present it here. We have 2 variables, so that one variable is the type of television, either black and white or color. The other one is size. We can represent either way. Right? Right. Further, equality of two matrices. Equality of two matrices. By definition, matrices A and B are equal if they have the same size and if they are corresponding entries are equal. So we try to say, what do you mean by equal matrix? Right? So it should fulfill two things. It should have same size, number of rows and number of columns, and the corresponding entries are also should be equal. Suppose let's say A is a matrix 2, -3, 4, 8, 6, 9. Let's say another matrix B 2, -3, X 8, 6, 9. Okay? If we can say these two matrices are same, right? I'll take one more example, one more. Then we could say X equal 4, Y equal 6. Under the condition that these are same. Right? If this is same, we should say it should be same size. Right? The entries also. Right? For example, let's say another C 2, -3, 4, 8, 6, 7. Can we say A is equal C? Matrix A is equal C?
No.
No, because you see here, the element, these two elements are not same. Even the size is same. The last element is not same. So A is not equal C. Right? A is not equal C. Right. Let's look at some matrices, how we demarcate the elements. The first element, it's given as A11. Right? Aij, this is indicating the row, position on the row. This is indicating the position in the column. So 1, 1 mean first column, sorry, first row, first column. 1, 2 mean first row, second column. 1, 3 means first row, third column. A21, A22, A23, A31, A32, A33. Right? So A11 means element in the first row, first column. Right? A23 means second row, third column, and so on. Any questions?
Yes, sir. Sir, is it possible to start the row and column count from 0?
I didn't get it.
In computer science, we're going to the index from 0. So it is possible to use it in matrix.
You mean this is 0?
No, sir. The A11 we're going to call as a A00 likewise.
Yeah. Any, because this number, I simply put it, everyone can understand. First row, first column. First row, second column. You can start A00, right? A01, huh?
Yes.
A02, something like that. Yeah,
Yes.
that is also possible. But here we are not going to use it in any computer languages. Maybe that may be the reason. But the person who is looking at the matrix should be able to identify, because later we are going to do some multiplication and so on. So that first row, first column, identifying using this 2-digit would be much easier for everyone, right? Even those who are not in the math stream can understand the elements. So sometimes when you say 00, they may confuse, right? So when you say 11, these are same actually. In your case, these are same. First row, first column. These also first row, first column. Yeah. Right. Okay. So we will have the same adaptation as I have instructed. So we will have it in a similar way. Right. So we could simply number all the elements based on which row it is present, which column it's present, right? Right. Now, let's move to the other information. Let's say a matrix A, 2, 3, 4, 5, 8, 9. Look at another matrix. What do you think about whether it is same matrix? I mean, whether the matrix A and B are equal? Or not equal? You see, all the elements are same in both matrices.
Not equal.
Not equal. We can argue this in two ways. First thing is, this is how we indicate the size of a matrix, 2 into 3, that means 2 rows and 3 columns. This is 3 into 2. First, the sizes are not same. Sizes are not same. How about the elements? Positions of elements. A11 is equal to B11. B11 means it is from here, this is from here. What about A12? is equal 3 is equal B12. Is it correct?
No.
Not equal. So you see, this is the problem. So when you say equal matrix, whatever the element that you are considering, 1, 2 should be equal to B12. Or A21 should be equal to B21. Right? So then only you can say it's an equal matrix. Right? So here, this is not an equal matrix. A and B are not an equal matrix. Right. Some definitions, right? Just to fulfill our notes. A matrix with one row is called as a row matrix, which is called as a row vector. So that means a matrix which is having only one row. There may be several columns, but only one row. Right? A row vector with k entries is the same as 1 into k matrix. Right? Let's take an example. A11, A12, A13, and goes as A1. Okay. So this is 1 into k matrix. So this is called as a row vector. Right? Similarly, we can have a column vector, a matrix with one column is called as column vector. So that is again in a similar pattern. We could say A11, A21, A31, and goes up to AK1. So this is called as column vector of size k into. Okay. Right. If all the elements or entries, if all the entries are 0, that is a 0 vector. That is a 0 vector. For example, all the values are 0. This is k into 1. This is called as 0 column vector. Similarly, 0, 0, 0, 0. This is 0 column vector. 1 into K called as 0 row vector. So later we will be using all this information. So these are some information, basic information. 0 column vector, 0 row vector. Right. Next, we will look at matrix addition. Matrix addition. Right. First, we will define what is matrix addition. Then we will do an example. If two matrices A and B of the same size are given, then the sum of A and B is the matrices obtained by adding corresponding entries of A and B. So that is basically called as addition, matrix addition. If two matrices A and B of the same size, so this is very important in the addition, right? Matrices should be being same size are given, then the sum of the two matrices is the matrices obtained by adding the corresponding entries of these two matrices A and B. Right. Addition. Addition is not defined for matrices with different sizes. So you see, the size has to be same for the addition, not matrices. If the size is not same, then you cannot add. For example, matrix A is with, let's say, elements 2, 8, 5, 3, 4, 1. Matrix B is equal -3, 2, 3, 4, -1. If you add these two matrices, it's simply you add the corresponding elements. For example, A11 plus B11, or A22 plus B2, etc., etc. you add the elements. So we could say the new matrix, let's say A plus B, can be with the new elements, which after adding, first one is -1, 10, 8. You add the corresponding elements. 7, 3, and 4. So this is the addition. Similarly, subtraction, A minus B, the similar concept. A minus B or B minus A. Here I have A minus B. So 2 minus minus 3. That means 2 minus minus 3. That is 5. 2 minus 2, sorry, 8 minus 2 is 6. 5 minus 3 is 2. 3 minus 4 is -1. 4 minus minus 1 is 5. Then 1 minus 3 is -2. Any questions? Addition and subtraction, you do it in a similar way, no difference. You add or subtract, right? Right. Now, so furthermore, on matrices, right? Whether you first take in the addition A plus B, right, is equal B plus, whether you add A with B or B with A, you end up with the same answer. Right? How about subtraction? Subtraction, not same all the time. Depends. Right? Subtraction, not same. A with B or B with B minus A is not same all the time. Sometimes it's true. If all the values are large in one particular thing, then it will be -1. Right? Right. Then we call it as a zero matrix. Earlier we talked about zero vector that will have either zeros on the column or zeros on the row. Zero matrix, or sometimes it is also called as null matrix, because nothing is there, only zeros are there in all the element position, right? So for example, I have a 0, 0, 0, 0, 0. So this is a 2 into 2 matrix, right? Another one, three into 2 matrix. So likewise, you can write any zero matrix. All the elements are 0, right? So here, when you add a matrix with zero matrix, this is called as a zero matrix, although it has zero matrix, right? So when you add a matrix with zero matrix, it will produce A. For example, if I have matrix A here, 2, 8, 5, 3, 4, 1, it will produce the same with zero matrix. So that means 2, the problem here with the software. Etc. Can you all see the screen? That's some problem in the software. Right. Let's say a matrix A, 2, 5, 6, 3, 4, 8 is a matrix. O matrix or zero matrix, 0, 0, 0, because it should have the same size. So if you add A with zero matrix, it should be equal to A. So that means you add the values from 2 plus 0, 5 plus 0, 6 plus 0. This will give the A matrix. Right? Right? So that is about the zero matrix or the null matrix. Right? The next one is called as scalar multiplication. Scalar multiplication. Scalar means it is a constant. But you're multiplying all the elements by a constant value. That is basically called as, in simple terms, scalar multiplication. Right. Suppose, let's say, if you are multiplying matrix A by a constant K, right? So that is K into A11, A12, A13, A21, A22, A23, A31, A32, A33. So you simply multiply all the elements by a constant where A is the matrix. So the answer would be simply K into A11, K into A12, K into A13, K into 21, K into, sorry, KA21, A12, KA12, KA21, KA22, KA23. So Deepika, are you traveling or what you are doing? Those who are without number, I will remove it. So these are 3 into 3 matrix, right? Silavan, can you mute it? Silavan, have to mute it. Right, if you multiply by scalar, it will multiply all the elements by scalar, right? So to multiply, I mean, when you multiply A and Ka are the A matrix A and Ka after multiplying by scalar are the same size. Size will not change when you multiply by the scalar. Right. The next one is square matrix. Square matrix. Square matrix. Let's say A is a square matrix where the number of rows equal to number of columns. Number of rows is equal to number of columns. That is called as square matrix. So this is another square matrix. This is having 3 rows and 3 columns. So this is called as square matrix. Right? So the number of rows should be equal to the number of columns. So that is called as square matrix. The rest of the matrix are called as rectangle matrix. Right? Rectangle matrix. For example, let's say A is 2, 8, 5, 3, 2, 9. So this is 2 into 3. So the sizes are different. The number of rows not equal to number of columns. They are different. So this is a rectangle. Matrix. Rectangular matrix. Right. Any questions? We are learning very basic ones, one after the other. Next one is the negative. Of a matrix which is simply given as minus A. Right? Negative of a matrix is actually minus 1 multiplied by 8. So here we could say the scalar may be minus 1. Suppose let's say a matrix A is equal to 5 minus 4, 6, 3, 2. So the negative of a matrix is given as you simply multiply by the minus 1. So that it will be minus 2, minus 5, 4, minus 6, 3, minus 3, minus 2. So this is you are multiplying by a minus 1. Minus 1. Right? Right. Another example. If I have a matrix A minus 3, 9, 4, 5, 2, 1, 6, 8, 3. So these are 3 into 3 matrix. It's a square matrix. We can suppose, let's say, if I multiply by a scalar 3a, this will be simply as minus 9, 27, 12, 15, 6, 3, 18, 24, and 9. Similarly, if you have minus a, negative of matrix A, 3, minus 9, minus 4, minus 5, minus 2, minus 1, minus 6, minus 8, minus. Right? Right. Now we are moving to matrix multiplication. Up to now we were doing very simple addition, subtraction. So matrix multiplication. Right. When you multiply two matrices, certain things that you'll have to consider, especially the number of rows and the number of columns. All right. So how we can define the matrix multiplication, right? By definition, A and B are matrices in which the number of columns of A is equal to the number of rows of B, right? When you multiply A and B, A with B, number of columns in A should be equal to number of rows in B, right? Then AB, a second. Then AB is a matrix that has the same number of rows as A and the same number of columns as, okay, same number of rows as column and same number of same number of rows as A and same number of columns as B. Right? Right. This can be expressed in mathematical form. So matrix A, where we indicate the matrix A with the size M into P, whereas the second matrix B is given as P into N. So we set the number of columns in the first matrix should be equal to the number of rows in the second matrix when you multiply. It should be same. Then the AB matrix with the size of M into N. Okay, M into N. So that is how we can indicate. Right? So this is in a simple form. So we could say, suppose let's say matrix A, we can elaborate with A11, A12, goes up to A1P, number of columns, A21 can go to A number of P here. Sorry, number of rows. Number of rows, huh? A, that is M1. Number of rows, M1. Here, this is A, MP. So this is M into. So number of rows is given by M for a first matrix. Number of columns is given as P. If you want to multiply, the second matrix should be A11, A12 into the number of columns may be different, not A. I'll put it as B, yeah. B11, B12, B1N. Okay. Similarly, here B P1. Here B P into N, BP N. So the size is P into N. Then only you can multiply A with, right? So everybody knows this first digit is row, second digit is column. Don't forget that. Always first digit is row, second digit is column. So the AB, let's say this is C11, C12, up to C C1N. Okay, C1N. Similarly here, C21, C22, CM1. This is C MN. So this new matrix will be given as m into when you multiply, right? So here, the elements, for example, if you take the elements C11, or I'll give a general one, right? Cij, that is the AB matrix, is given as AI1 into B1j plus AI2 into B2j plus AI3 into B3j, right? Likewise, it goes up to the last point, AIP into BPJ in general form, right? So, for example, if I say C11, it is equal to A11 plus, A11 multiplied by B11. How about C12? Multiplication of C12. Look at here. Yeah, C12 is A12 multiplied by B21. Similarly, C13, right, is equal A13 into B31. So likewise, you can write it down. Right, we will take a very simple example. Matrix A is given as 2, 3, 4, 8. I'll take another matrix, matrix B, simple matrix, 5, 3, 4, 1. So this is also 2 into 2. This is also 2 into 2. We can multiply this matrix because when you multiply A into B, the number of columns in A should be equal to number of rows in second matrix. So that is equal in this case because it is a square matrix. Right, how to multiply? Very carefully look at it. Those who are learning for the first time. This first row of first matrix multiplied by first column of the second matrix. What is that? That means I will keep some space for that, for multiplication, right? So that means C11 is given as 2 into 5 plus 3 into 4. So what is that? 2 into 5, 3 into 4 is 22. Huh? Am I right? Right. What is C12? C12 is 2 into 3, first row and second column of the second matrix. So 2 into 3 plus 3 into 1. So that is equal 9. Okay. Right. Fill the rest. C21 is equal 4 into 5 plus 8 into C22 is equal 4 into 3 plus 8 into 1. So this is equal how much? 52. Eh? Right. Very simple now. Right? Right. I will write down two matrices. Can you give the answer? So this is 1, 2, 3, 4, 5, 6. Three, 4, 5, 6. 1, 2, 0. So here this is 3 into 2. This is 2 into 4. So you see, number of columns in the first matrix should be equal to number of rows in the second. So we can multiply. Now give me the answer. AB. I'll give you 5 minutes. Give me the answer. Anybody who got the answer? You can tell row-wise the answers.
Sir, can I tell the answer?
Yeah. Row-wise, huh?
Oh, yes, sir.
First
5.
of all, how many rows and how many columns are there?
3 rows, 4 columns.
Yeah. 3 rows,
4 columns.
4 columns. Yeah.
Row wise.
Go ahead with the answer. Tell me row-wise, huh?
Okay.
First
5.
row, second row, and so on. Yeah.
First row is 5.
Yeah. First row, start with 5.
8.
Give me a second. Yes.
5.
Mm.
12.
Mm.
Second row 13.
Mm.
20.
20. Okay.
15.
Mm.
30.
Mm.
Last row 21.
Mm.
32.
Mm.
25. 48.
Good. Anybody need any clarification how the values comes? Anybody need any clarification? If you need, open your mouth and tell me. Right? Right. How this 5 comes? First row multiplied by first column. What is that? 1 into 3 plus 2 into 1. How this 8 is coming? First row of the first matrix, second row, second column of the second matrix. So 1 into 4 plus 2 into 2, that is 8. This value, first row and third column. So that is 5. Multiply and add it. 1 with 1 into 5 plus 2 into 0. Then the last one, first row and the last column. So that is 1 into 6 plus 2 into 3. So that is 12. Then you go for second. Right? We go for second row with first column. That means, give me a second. Yeah, second row with first column, 3 into 3 plus 4 into 1. So that is 13. Then second row with second column, that is 3 into 4 plus 4 into 2. Right? That is 20. Then 3 into 5 plus 4 into 0. That is 15. The last one is 3 into 6 plus 4 into 6. That is 30. So likewise, you go for the third. Right? You need to practice. If you don't practice, you will be in trouble. Right. Now, what do you think about? I am multiplying A with B. If I multiply B with A, do you think this answer is equal? Is it equal or different? Anyone? Ahmed? If you multiply A with, A with B, is it same as B
No,
with A? No.
yes, because number of columns going to be changed. That means 3 by
Yeah. Yes, number of columns.
going to be changed.
Yeah. Later we will see under certain circumference, this can be equal. What is that?
For square matrix, it may be equal.
Square matrix, yes.
Yeah, square matrix. What square matrix? We didn't talk about this square matrix. Is it true? Let's say A is equal 3, 4, 8, 5. B 3, 2, 1, 5. What is AB? What is AB? Is 13. 26, huh? 29. 41. What is BA?
Different. Sorry.
Yeah. So not necessarily to be a square matrix, but we will see that under one condition.
If the entries inside A and B is same, then
But
if
it's,
the entries of A and
we
B are
will see that later. Yes. That is called as identical matrix. We will come to that later. But mostly this is the case. Huh? A is not equal B. So keep in mind, A is not equal B. Yeah, some homework before we go for the quiz. Right. So we have a homework. I'll give a couple of homework. I don't know whether we have enough. So let's say matrix A is 2, 3, 4, 6, 8, minus 2, 4, 5, 7. Matrix B, okay. Matrix C, Right. So find out AB. A plus B. A plus. Sorry. Right. Right. These are the homeworks. Find out. Right. Any questions? We will continue. Some more theory next time. There are some application. We will see that later. Still, we are in the learning process. Any questions? This is the question, right? Homework. Three matrix ABC has been given. You have to find out all these different computations, adding, subtracting, and multiplying. Right? Any questions? Yeah, maybe in the afternoon session, before I give the quiz, better to speak to Professor Samita and see the possibilities to have the exam in the afternoon. Majority asked the exam in the afternoon so that we can have it in the afternoon, right? Anyhow, we'll have to confirm it, right? Right. We'll go for the quiz. This is the quiz. So my function has been given as y is equal 3x square plus 4x divided by 4x square plus 2. Find out the derivative dy by dx. Even if you need not to solve completely, even the first step is more than enough. One step, you don't want to simplify. One step is more than enough. Right. Okay. We start. those who are attaching the file will not be marked. From the beginning, I said those who are attaching will have to type the answer. Because I know those who are those who are sending the files, they are on mobile phones, it seems. One more minute. Okay, see you tomorrow.